Hello, my name is Joseph Fernandez. I am the robotics and computer science teacher here at Sun Lake High School. I want to talk to you about robotics in general and what we cover in robotics, what we do in robotics. So the idea here is we're going to combine science, technology, engineering, and mathematics with computer programming to make a better and brighter future, just like the slide says. And there's a lot of different things we do in robotics. So first up, we learn about the history of robotics. So we learn where the term robot comes from, where the term robotics comes from, and we learn about early robotics and robots up until modern robots today. We learn about how we design robots, what skills. The engineering design cycle, as an example, is a skill set that helps people learn how to design and build things, specifically from start of the problem to the finished solution. We actually build robots. So every of the 4 different robotics courses, there's a whole year-long project where we build and design a robot or device that will run and perform some tasks. So, and obviously the tasks get more complicated as the years go on. We make robots do what we want them to do. So we also learn about programming, program methodology, artificial intelligence, and those type of things. So we get the robot to do what we want the robot to do. As part of the overall concept of engineering and robotics, one of the things we're going to have to learn is skills in mechanical engineering, such as drafting, which you can see an example of either in 2 dimensions, or you also see an example using SOLIDWORKS in 3 dimensions. We obviously have to go over physics related to robotics, laws of motion, kinematics, simple machines, gears, as you see there, mechanical properties of materials, tolerance and allowance. We go a lot more into hydraulics and pneumatics and a lot of other different topics. So it's basically we cover a lot of principles of mechanical engineering as part of the robotics courses. We also learn about engineering technology, such things as rapid prototyping, 3D printing, use of virtual world analysis testing to test robot designs in a virtual environment. We also learn about collaboration, presentation of material, and proper technical writing techniques. It's what's covered in those courses. Also, some simulation and modeling is covered as well. Computer programming, control systems, obviously it says artificial intelligence. We talked about programming before. Artificial intelligence are just complicated programs that allow the program or the program in a robot to act as if it was human intelligent. We learn programming languages such as Robot C, C++, Python. We also do comparisons to Fortran and assembly. We can make robots learn information, be autonomous, means runs on their own. We do, again, like I said, mathematical analysis and modeling of our systems, of the robots, of the sensors, and what they perceive in their environment. We obviously have to learn electrical engineering because robots run off electricity. So we learn about electronics and circuits. We learn how to solder. We learn how to use electrical measurement equipment such as multimeters and oscilloscopes. Oscilloscopes are pictured there, to measure things like voltage, current, capacitance, resistance, inductance, and so forth. So what happens in robotics in all the courses? We do things, we learn about things, and in the end, we also have fun. So I've talked about the robotics courses. I wanted to talk a little bit more about specifically the 4 different courses. Each course is a year-long course. Each course is an honors course. And the first course you're going to take, obviously you see this in order of Foundation of Robotics, Robotic Design Essentials, Robotic Systems, and the last course, Robotic Application Capstone. So Foundation of Robotics. It's the entry-level course in the 4-course pathway or academy we have here at Sun Lake. It is available for students of grades 9 through 12, so they can take the course. From that course and the courses that are going to follow, You can work on getting a pre-engineering and robotics associate industrial certifications. Also, there is you can get some manufacturing industrial career application to what you're going to be learning. This pathway starts a 3 to 4 year course to work on what's called the SolidWorks Certified Associate Industrial Certification. Talk a little bit more on that later on, but this is one of the courses where we start learning about SolidWorks. So it's going to help you towards gaining an industrial certification. Generally, industrial certifications require you to pass a industrial certification exam. It's true for the pre-engineering robotics associate industrial certifications, as well as the SolidWorks Certified Associate Industrial Certification. Subject covered in this course are the history of robotics, laws of motion, basic electronics, simple machines, programming, specifically Robot C, 2D and 3D drafting, obviously the engineering design cycle. We're also going to have a course in workplace safety based on the OSHA workplace safety course that they provide. We're going to learn skills and practice doing teamwork and collaboration throughout the course. We're going to learn about things called logic flow diagrams, basic logic gates that make sense, are used not only in marketing and business, but are also used in engineering and a lot of other topics. The second course in the 4-course pathway is called Robotic Design Essentials. Generally, this is offered to students of grade 10 through 12, though a student of grade 9, if they've taken the foundation of robotics previously in middle school or such, could also take this course at that level. Generally, though, you should take the foundation of robotics course prior to this course. Again, during this course, you can still obtain the pre-engineering and robotics associate industrial certification and work towards that if you haven't already got it. Things I cover in this course: more advanced electronics, advanced programming. I cover C++ and Python in this course for programming. Also, we include automation programming as well. A lot more advanced 2D and 3D drafting. Higher level engineering design concepts are going to be going over as well. I'm going to do a lot more advanced coverage of a lot of the stuff I covered in the prior course, Foundation Robotics. Clearly, teamwork and collaboration will still be in place. A lot more advanced mechanical physics principles will be covered as well, and of course, a lot more. Robotic Systems is the third course in the 4-course pathway. Generally, it's offered to grades 11 and 12. Though again, if you've taken the prior 2 courses, Foundation Robotics and Robotics Design Essentials, you could ideally take this course earlier. Again, it also not only allows you to get the pre-engineering robotics industrial certifications, but at this point, if you've taken this course and the prior 2 courses, you should be ready to take the SolidWorks Associate Industrial Certification, the SolidWorks Certified Associate Industrial Certification exam, which is a very common industrial certification required in design and engineering, similar to other 3D modeling software. We, of course, cover subjects including advanced control systems, advanced programming, including artificial intelligence programming. We'll bring in Fortran and assembly to show the history of robotics programming and similar codes that are still used in the industry that are not the more common things like C++ and Python. We also go into industrial manufacturing, engineering, design as well. Teamwork and collaboration again. More advanced mechanical physics on top of everything else. We do a lot more computer simulation and modeling as well in this course. Look at a lot more different programs that do facilitate that and what type of results we can get. This course tends to be a lot more on the higher level of modeling, simulation, control systems, and a lot less more physical and more virtual representation and design of a project. Here, students move away from simple robotic pre-made parts and usage to build a robot, and they're actually building the robot from scratch, from materials that are purchased, and they construct and they manufacture and assemble and program and solder and put everything together. So this is where they're really starting to build robots on their own. Lastly, we have the Robotics Application Capstone. This is the fourth course. Generally, you need to take the Foundation of Robotics, the Robotics Design Essentials, and Robotic Systems prior to this. So it's generally really only offered for the seniors, grade 12 students. Here, as always, you can get the pre-engineering robotics industrial certifications. If you didn't get the SolidWorks Certified Associate certification in systems, you can definitely get it here as well in the senior year. Really, we're taking all the material, all the skills and understanding that we learned previously, and we're actually applying it to real-world problems and solutions and building a robot that is a solution to a problem that they determined was important, the group of students in this case. They design it, they analyze it, they model it, they do numerous presentations, so professional engineering skills and research, analysis, presentation, and reporting. This is where heavy amount of technical writing, critiquing, and improvement will occur. They will make a very large document. They will make numerous presentations of numerous different types throughout the year as well. They're going to go a lot more into finding out and searching for themselves the components they need for a device, finding them, assembling them, constructing them, design, and so forth. We'll look more into the commercial, industrial, manufacturing, engineering, design concepts, analysis, still more teamwork and collaboration. We are still going to be doing SolidWorks as well, so they'll get to the point where they should easily be able to take and pass the SolidWorks Certified Associate Industrial Exam, certification exam, and be able to use SolidWorks comfortably. They should be also use any of the prior software or materials or systems or parts that we've used previously, motors, gears, sensors, valves. They can incorporate any sort of different type of mechanism in their robot. So it's a lot bigger, grander design, and they really are focusing more on doing the proper procedure. There's even a mock-up scenario where they are part of a business or company that's been given the task to design and build a robot. So they immerse themselves, and that's where the capstone aspect comes in, where they're actually doing what engineers in the workforce do. So that is a short summary of what's covered in the robotics courses. Obviously, there's a lot more stuff. I can spend a lot more time talking about it, but I wanted to give you a short synopsis, a short summary, if you will, of what's covered, what things we do in there, show you some pictures of stuff. This picture specifically was a previous design that they put together in the modeling software to show what their entire robot would look like as a diagram before they assembled it. So they learn about that as well. All right. Well, if you have any questions, I should be available for a question and answering period, or you can email me at jrfernand@pasco.k12.fl.us. Thank you very much for your time.